Hi Year 12 Maths General students. This lesson is from Unit 3 General Maths, and we're looking at the role of the slope and y-intercept in the linear models we may have developed to help in our statistical analysis of bivariate numerical data. So the lesson objectives today are reviewing the meaning of the slope and y-intercept in the context of the data being analysed, and within that, just recognising the limitations of modelling scenarios given some logical assumptions within our model. Last lesson, we looked at the general form of a regression line. A is our y-intercept value, where the x value is 0. So that's given our model, that's showing the average value of our response variable when our explanatory variable equals 0. So that potentially represents the initial or starting value of the model. For our slope value, that, remember, is the gradient or rate of change line. And we're looking at the average change, whether it's an increase or decrease, in the response variable for each 1 unit increase in the explanatory variable. And we need to be able to interpret what those slope and y-intercept values mean in the context of every scenario we're analysing. It's also super important that when we model our scenarios, we recognise that there's limitations to the model. So using what we know from strengths and limitations, each time we develop a model for a scenario, we need to consider what's good or bad about our model that we've developed. So we always need to be asking ourselves, was the data used to construct the model reliable and accurate? Was there a sufficient amount of data to analyse? How accurately does the model aid in making predictions? So how accurately can it predict a given explanatory or response variable value? How effective was the model in painting a picture of the relationship between our explanatory and response variable? Were there any values that just don't make sense? And what aspects could be relevant when constructing the model that weren't or were considered? Okay, let's have a go at analysing the meaning of some slopes and y-intercepts, given some example questions. Now I've got 3 example questions to try. Each one I've worded in a simple familiar type language to help us get used to this idea of interpreting slope and y-intercept. Starting with question 1, we've got an equation of a regression line that was developed to model the relationship between the price of a car and the car's age. The model we've been given is the price of the car, so that must be our response variable. So the age must be our explanatory variable. Now, this is written a little bit back to front, so it looks like this 42,300 is our A, 2,350 is our B. So if you want to rewrite that to be a little bit more understandable in terms of the model we're used to, simply rewrite it, and now it's in that more familiar format of our response variable is the slope times the explanatory variable plus our A value, or another way is that. Part A is asking us to interpret the y-intercept of this model in the context of the data. So if we look at what our y-intercept is, it's the $42,300. So knowing that that's our A value, we associate that with our starting response variable value when our explanatory value is 0. So in other words, when the car was 0 years old, the price of the car brand new we're predicting is $42,300. So you would just state something like this. For part B, we want to interpret the slope of this model into the context of the data. Now remember, the slope is the average change, so an increase or decrease, and the response variable for each 1 unit increase in the explanatory variable. So if I'm looking at that slope value, we have negative 2,350, and we're talking about dollars per year, so the age of the car. So interpreting that, I would say something like, for every year the car ages, the price of the car decreases by $2,350. So you would write some sort of statement like that. Looking at part C, we want to identify any limitations to this model as the age of the car exceeds 18 years old. So if I think about this visually and I do like a little sketch of the graph of the model, so I'll just move this down to make a bit of room. So I'm going to do a sketch. Just a sketch, it's not going to be to scale. I know that it starts at $42,300. It's a linear model that's decreasing. So at some point, it's going to cross this x-axis. So we could check where it does cross the x-axis. To test the model, I'm going to find the price after 18 years, because that's what it's saying, exceeding 18 years. So if I type that in, I get 0. Okay, so what we've seen is it crosses the x-axis when the car is 18 years old. And below that, it means we're going into negative values of the price of car. So if the car was 19 years old, I'd have a negative worth. And that's impossible. So that's a limitation of the model. So just stating that limitation, once the car gets over 18 years old, it has a negative price value, which is not possible. So that's an obvious limitation of our model. Moving on to example question 2, we've got data showing the results of a survey on a group of people looking at the effects of stress levels, which is measured by the amount of the hormone cortisol in the blood, on blood pressure in the person. So we've got some data there, looks like 12 bits of data. They want us to identify the explanatory and response variables. Using your calculators, determine the least squares regression model equation. Rewrite the equation in the context of the data. Interpret the slope and Y-intercept, and then identify any obvious limitations to the model in terms of blood pressure or cortisol levels. Have a go at the question. So press pause and we'll check in with how you went. If you're a bit stuck on part B, a quick refresher on how to use your calculators. Go to mode, select option 2, the stat 2 for A plus BX. We enter in our data. Just do a quick check to make sure you've entered in all of your data correctly. Press clear. We want to access the stat option, so shift 1, and we're after 5 reg. We want the A and the B value, so select 1, press equals. Select 2 for B, press equals. That allows us to come up with our least squares regression model equation. Rewriting the equation in the context of the data, we should have blood pressure is 2.23 times the cortisol levels minus 100.87. For D, our 2.23 is our slope value. So that means we're getting an increase of 2.23 units of blood pressure per 1 unit increase of cortisol level. In other words, your rate of blood pressure increases as your cortisol levels increase. Moving on to E, our Y-Intercept. Now, this presents where we have an issue with our model. So the Y-Intercept interpreted means that we have a negative 100.87 blood pressure when cortisol levels are 0. So in other words, that means someone with no cortisol in their system has negative 100.87 blood pressure. And I'm no doctor, but I'm pretty sure you can't have a negative blood pressure. So that helps us address part F when we're looking at the limitations of this model. So I would probably write something like, people can't have a negative blood pressure, so there appears to be limitations on some of the predicted blood pressure and cortisol levels. Looking at our last question, this is considering the current investigation we're doing with our 20 people who were sampled on their arm lengths and heights. And remember, we're looking for a predictable correlation between someone's arm length and their height. And we came up with the model y equals 0.821x plus 30.69 when we performed the linear regression. I've just copied across the graph that we came up with to help us answer the questions. So part A wants us to rewrite the model equation, interpret the slope and y-intercept all in the context of the data. And then for part B, given we're thinking about possible limitations of our models, can we identify any limiting issues with the model in terms of values of someone's height and arm span? So have a go at it, press pause, and we'll check in. All right, so hopefully you got a model equation where our height is our response variable, which equals 0.821 times arm span plus 30.69. So interpreting your slope, we get a height increase of 0.821 centimeters for every 1 centimeter arm span increase. For the y-intercept, this is where we're finding an arm span of 0 centimeters, and it's saying that we have a height of 30.69 centimeters. So thinking about that logically, that's impossible. We can't have an arm span of 0 centimeters. I mean, maybe in your mum's tummy, when your arms are first growing, you could have an arm span that's close to 0 centimeters, but you certainly wouldn't be 30.69 centimeters tall at that stage. So that helps us answer B. The limitations are there's just some values of height and arm span that aren't possible using the model. Alrighty, so hopefully that's helped grasp the concept of slope and y-intercept when we're trying to analyse what they actually mean in terms of the data we're analysing. So our y-intercept is where our explanatory value is 0 and our corresponding response variable value, and our slope is our gradient or rate of change, looking at the average change, increase or decrease in the response variable for every 1 unit increase in the explanatory variable. And the other message is just be really cautious when applying your models and think about the limitations of the model. Thanks, Year 12s.